Alright, so in this video I'm going to go over a homework problem 320, which is from our homework number 13. You were asked to sketch a graph and describe the graph completely for a cubic function. This is a cubic function. And before I start graphing, I would describe its transformation. It looks like h is -2, k is +4, which means that the graph has been shifted left 2 and up 4 from its parent function of y equals x cubed. So I would start by identifying the locator point, and that's going to be h comma k, which in this case is -2 comma 4. So -2 comma 4. Okay, and generally we have our y equals x cubed function, which goes through the origin, and it has 1 comma 1, 2 comma 8, so the other way as well in the negatives. So the general parent cubic function looks like this. But since it's been shifted left 2 and up 4, we're going to move all those points of a parent cubic functions left 2 units and up 4. And if we move this point, we should be moving it to the locator point. So left 2, up 4. And this one here is going to be left 2, 1, 2, 3, up 4. And then this point will go left 2, 1, 2, 3, up 4. This one will be left 2, 1, 2, 1, 2, 3, up 4. So then looks like my graph will look something like this. Okay. So then now we're going to have to describe the function. The shape of it is going to be cubic. There's no line of symmetry, right? No line of symmetry, meaning if you were to cut it in half vertically or horizontally or diagonally, it's not going to be a reflection of each other. There are no asymptotes. Okay. The domain looks like it's going to be all real numbers. Same thing for the range. It's going to be all real numbers. Right? Now, as for minimums, there's no max or minimum. There's no highest point. There's no lowest point. It just keeps going up and keeps going down. Now, the main thing is going to be finding the y-intercept and the x-intercept. Let's start with the y-intercept. Y-intercept is when y is equal to 0. X is equal to 0. So in our equation, if we were to set x equals 0, you should have y is equal to 0 plus 2 cubed plus 4, which is going to give you 2 to the power of 3 plus 4. And 2 to the power of 3 is 8. So you would have 8 plus 4, which is 12. So my y-intercept, it should be y comma 12. And I know it doesn't look like it in the graph, but I guess I can do a better job of making it so that it looks like it goes through 0 comma 12 like this, right? I can fix my graph. So I got my y-intercept. The x-intercept is where I saw many students struggling with. That's when the y value is equal to 0. So I'm going to plug in 0 for y. So 0 is equal to x plus 2 cubed plus 4. Subtract 4 both sides. So now I got -4 equals x plus 2 cubed. So then I would cube root both sides, because I got to solve for the x. I got to undo the cube. So that's going to give me x plus 2 equals cube root of square root of -4. There's no plus or minus. Plus or minus does not exist when you cube root. Okay? So it's just going to be either positive or negative. In this case, it's going to be a positive cube root. So then subtract 2 both sides. So you can say your answer x is going to be negative 2 plus cube root of negative 4 as your final answer for the x-intercept. Okay, and we're just going to assume that somewhere right there, that's going to be our x-intercept value. Now, if you do really care, I'm going to suggest that rather than writing it as cube root of negative 4 minus 2, I would prefer this way, the one I wrote originally. Because many times when students write a constant, write a number after the root, sometimes the way they write, and this is the reason why in math rule we write it this way, because it's we write a number behind the roots, sometimes it's hard to tell whether that root is under the same constant or not, right? So therefore, we made up a not really an official math rule, but it exists, is that whenever you have radicals, it goes always to the back side of your solution, and you leave a constant at the front. So separate that one number is outside the root and the other number is inside the root. Okay? Right?